Excellent. I think we'll kick it off. There's probably going to be a few more participants joining as we go. You've made it to room 5. We'll have the pleasure of talking about image metadata extraction at scale for online classified platforms. Before I hand it over to our speaker, there's just a couple of logistical items. So we are recording this session. So please keep that in mind in terms of thinking about whether you want to share your video or not, whatever you feel comfortable with. I will in a minute post a Slido link and the password. This will allow you to ask questions on our conversation and on the talk we will be hearing throughout. And you can also upvote questions by other participants that you find particularly interesting. So feel encouraged to use that. I'll just post it a couple of times so it's easily accessible and sort of streamline the questions there so that in the end we can focus on the most popular questions. I will also be sharing a poll or a small survey on your experience with the overall event towards the end of the event. Would be really, really grateful if you could all fill it out to help us learn for the second datalift event, which is coming up in November. So thank you in advance for participating there. But yes, so without much further ado, just a brief introduction. Today we'll be enjoying a talk by Alexey, who is a software engineer with a focus on machine learning. Welcome. Currently working at the OLX group. This is a global marketplace for online classified advertisements. And he's a lead data scientist there. He's also a Kaggle master and the author of a book, which I believe came out just recently, the Machine Learning Bootcamp. So make sure to check that out. I'm not sure, maybe you have a link to share with us. So yeah, happy to hand over to you. I'll just give you the host control so you can share your slides. And so we'll have about a 10-15 minute talk, and I'll share the Slido link now for you to ask questions throughout. I'll stop sharing so you're able to share.
Okay, is everything visible?
I can see it well. I hope the same one for our participants. Feel free to give us a little bit of feedback through the chat.
Okay, so I'm starting, right?
Great, yeah,
Yes.
Thank you.
Hi everyone, thank you for introducing me. It's a pleasure to be here. Today I'm going to talk about productionizing deep learning models. And the main challenge we had when doing this is how do we apply deep learning models to 10 million images daily. And if you think about this, 10 million images, it's a lot. If you spend only 1 second looking at each image, then as a human, you will need to spend almost 4 months doing it non-stop. That's a lot of time. That's a lot of images. So how do we solve it? How do we scale deep learning models to this amount? This is the main challenge, and this is what we'll talk about today. First, I'll tell you a bit about OLX. So OLX is an online classifieds website, which is present in many markets across the globe. So now you see OLX, Romanian OLX. So this is basically the place where you go to sell items that you don't need anymore, or if you want to buy something secondhand, perhaps. So typical items there are cars, like houses, and pretty much everything. Clothes, electronics, you can imagine. Like everything you can sell there. And for us, it's interesting to know what is on these images, because images are important. Images, this is what people see the moment they enter the website. This is what helps them to make a decision if they want to click on an ad to read more about this or not. So we want to know what is on images. We want to know if it's a house, if it's a car, if it's a mobile phone, or maybe somebody is trying to sell something that they're not supposed to sell, like a weapon, a machete. And of course, in these cases, we want to stop that from happening. We want to react as fast as possible. So basically what we need is an image classifier that that can tell us what is on each image. Is it a truck? Is it a fridge? Or is it a weapon? That's one of the things we need to do. So build an image classifier that can detect many categories. Another thing is quality of images. The quality of images is pretty important. As I said, for people to decide if they want to click on an item or not, they need to have good visual impression of what this item is about. And if an image is good, everything is visible, then buyers are more likely to click on this image and eventually reach out the seller to get more details. But if an image is not good, if the quality is bad, maybe it's blurry, or the light is too strong, or it's too dark, things like this, or it's out of focus, then the likelihood that buyers will reach out to sellers is lower. So we want to detect things like this, understand that quality of image is good or bad, and if it's bad, then we can reach out to the seller saying, hey, like there are problems with your images, do something about this. Okay, I just saw that there are people waiting in the waiting room, so I just, since I'm host, I also let them in. So yeah, so knowing the quality of images, like if it's good or bad, is also important, and it's another classification problem. Then sometimes sellers put some text on images. They are not supposed to tell that, so they should mention all the contact details in description or in special forms, because when they do it like this, we have no way to understand like if it's a good phone number or maybe it's some fraudulent activity. So in many cases, we do not allow sellers to put their contact information on images. But some people still do that, and we want to detect cases like that, and we want to understand, okay, there is a piece of text artificially added to the image, and it's again a binary classification problem. If there is a text, then the model says yes, there is text, and otherwise it says no. And then last but not least, often some people, especially fraudsters and cheaters, may upload something that they are not supposed to upload. So it can be explicit nudity, for example. And of course, this is something we cannot allow people to upload and to post, and we want to stop that as soon as possible. For that, we have a special model we call not safe for work detection, but it's detecting mostly explicit nudity. And then, of course, if there's nudity on the picture, we detect that and we stop the listing from going live. So basically what we need, we have all these models. So I just told you about 4, but we have more. So we have all these models, and we need to apply all these models to these 10 million images that we have. That's a lot of images and a lot of models. So how do we do this? So the main idea is we have a thing that basically serves these models, and for every image that the user uploads, we apply this model and save the results to a database. And we call this thing the metadata service, because it keeps the information about each image, so metadata about image, what is there, the quality of this, and we call it metadata service. And this is how it looks like. So for deploying models, we used initially we used SageMaker. So we would set up a SageMaker endpoint, and then there was a wrapper that gets images from S3, does all the necessary pre-processing, like resizing the image, normalizing it, and then sending it to SageMaker endpoint, getting the results. And then there is the actual metadata service, the thing that our clients use, and clients in this case are other teams. So teams that want to get the predictions. So for example, it can be a moderation team that wants to know if there is a gun or not, or it can be some other team, for example, marketing team that needs to know if the images are good quality or not. So the user uses, the clients use metadata service to talk to the model wrapper, and then eventually talk to the model. And then all the results are saved to a database, and we can reuse this later without the need of recalculating the same thing for the same image. And for deploying this, we use Kubernetes. So all these things, they are put in Kubernetes. We use AWS for that. So SageMaker is a service from AWS. S3 is also a file storage, and everything runs inside Kubernetes, like all these extra services. That worked well. So we were able to use it for our campaigns, for detecting, for doing image classification. So that was good, but SageMaker turned out to be quite expensive. So it costed, like if we wouldn't use SageMaker, but usual EC2 machines, usual servers from AWS, it would cost 4 times less. So, and other thing is it was doing fine with normal traffic. Like let's say we have 100 images per second. So this is fine, but in some cases, maybe there is some marketing event. Sometimes the traffic goes up suddenly because of something, maybe just many users are registered. Maybe it's a day, a public holiday, so many people go to the website, or maybe something else. But for some reasons, sometimes people just start uploading a lot more images than usually. So it's also important to react to this kind of peaks in traffic. Having these two problems, SageMaker being expensive and having peaks in traffic, we ended up with this architecture. So first of all, we moved all the models out of SageMaker and deployed them internally in Kubernetes using TensorFlow serving, for example, and MMS, which is MXNet model serving for MXNet models. And then we added queues between the metadata service and the model wrappers, and that allowed us to react to peaks of traffic more gracefully. So instead of, when there is a peak of traffic, instead of killing all our services with this sudden surge, they would accumulate, like all these images would accumulate in a buffer, in a queue, and then we would gracefully scale out to process this traffic. It became asynchronous for the client. So the client submits a request and then waits till it finishes. So for our clients, it was quite difficult actually to do. We made our life easier, indeed. So we could react to all these peaks of traffic, and it made handling infrastructure a lot easier for us. But for the clients who used that, that was a problem. So because they needed to send the request and wait until we call them back with this. And especially for moderation, when they want to know if somebody wants to sell an item, to sell a gun or not, they want to know about this immediately. So they couldn't wait till we process through this peak of traffic. So imagine if there are 1,000 users trying to upload images, and then one of them is trying to sell a gun. Even though there is a lot of traffic, we still need to find this gun. So it was actually, at the end, it turned out not to be a good option for us to have this asynchronity. So what we did, we removed these queues altogether. Even though it made our life simpler, we still got rid of them and put all these model wrappers into a service called IMS, which would encapsulate all this logic of fetching images from S3, doing special preprocessing like resizing, normalization, because each model needs its own resizing and normalization. So they all lived in IMS, service we called image model service. And we got rid of all these queues. And this is the infrastructure. This is the how our service looked like at the end. We again made it synchronous, so we didn't have these buffers that we had previously, didn't have the queues. And the customers, the clients would simply use a simple HTTP call to talk to IMS and get the results. Then for caching, we ended up using Dynamo instead of MySQL as we did initially. It was a lot easier to scale, and MySQL required a lot of maintenance. And to solve this problem with peaks of traffic, we have to keep more instances running than needed. So we sort of, some of them are idle, not receiving any traffic, and they're just waiting in case there is a sudden peak of traffic, a sudden surge. And then, like when it happens, they start processing requests, and that allows our infrastructure, our Kubernetes, notice this and scale out, add more instances. So instead of using this queues that was convenient for us, we ended up over provisioning and adding more services that we needed. Most of the time they are idle, but when there is a peak of traffic, then they take the load, and it allows us not to operate and not go down. And I intentionally kept this pretty high level. So I'm quite interested in talking now in hearing your questions. But you can read more about this. We have 2 blog posts. So there are links. I'll share the links later. And you can also find me on the internet, LinkedIn or Twitter, if you have any questions. And there is a link to the book. And with that, I'm happy to take questions. Thank you for listening.
Thanks so much, Alexey. Wonderful. We do have one question. I think we don't have too many questions on Slido yet competing, so I'll just take the question from our chat, which is, will you be able to provide some numbers on how much data is going through the system in terms of data points, data volume?
Yeah, I think I mentioned, maybe this is from a person who joined later. So we're talking about 10 million images per day. So that's a lot of images.
Thank you.
It's up to 300 per second during peaks.
So since we don't have a huge amount of questions on Slido, also feel free to use the chat directly if that is easier for you. Don't be shy. I do have a couple of questions prepared that we can talk about while people maybe think more about the talk and share their questions. One thing I would be curious about, Alexey, is how you go about analyzing the image data and making it available to your data analysts.
So we have all this data here in Dynamo, but for analysts, this is not really convenient. So they don't want to go to Dynamo, check all that. So to make their life easier, and also since this is like an operational database, we don't want analysts touch it because, well, many things can happen, right? So for that, we have a replica of the data. And I actually have a backup slide here. So what we do is for everything that is uploaded to our image storage, or file storage, S3, so every time there is a new image, we immediately analyze it. So we use special things called event notifications. So when something is uploaded to S3, we get an event about this, get a notification, process it, get all the information we need about quality, about category, and then we eventually put it to another data storage. We use S3 for that, and we use Athena for querying. And basically, it allows us to decouple the analytical workloads that analysts have from the operational workload, like using this as a cache. And Athena is very scalable. So it's basically the data sits there on S3 when nobody needs it. We don't pay anything, but the moment somebody wants to run a request, so it's like sort of serverless, but for analytics. So the moment somebody wants to analyze some data, they would use this table in Athena from S3, and we pay for each gigabyte analyzed. So it's not like for time, but for each gigabyte we analyze, we pay a certain amount of money. And this is great. This is very flexible. And so analysts are happy, and we are happy because there is a separation between these 2 databases.
Right. Thank you. As I said, don't feel shy. We have another question, a couple actually. That's great, just coming in. One is, was your training data for the image quality prediction manually curated by experts internally, or how did you go about building up the data set itself?
Yeah, so it was both. So we used crowdsourcing, Mechanical Turk for that. So basically we would ask people, hey, what do you think about quality of this image? Is it good or is it bad? But of course, this is very subjective. So many people have different people have different opinion, like whether something is good or not. So we needed to show the same picture to 9 or 10 people. And then this would, like if 10 out of 10 people think this is a bad image, then this is indeed a bad image. If 5 out of 10 think it's bad, then that's maybe not that bad. And if 0 people think it's bad, then it's a good image. And basically, this is what we did. So we collected all this data, and then we took the average, and then we were trying to predict this average verdict from the crowd, from Mechanical Turks. And of course, we also had some data that we curated, like we generated internally by experts, and these experts are data scientists who just look at this data and see like, okay, it's good or not. And like I also labeled a few hundred examples myself. And yeah, so this is how we collected. I think we have like 5,000 or 10,000, I don't remember exact number, but reasonably large. So not super large data set, but enough for fine-tuning a usual like ImageNet model.
Question about TensorFlow serving. What are the key advantages of using it? And could you write your own prediction API, for instance, using Flask?
Yeah, so we kind of did this. So here, this IMS uses Flask. So this is the prediction API. But for TensorFlow serving, so TensorFlow serving uses gRPC for communicating. Well, it's also possible to use HTTP, but for images, it's very tricky. So what we do is we use some sort of, you can call it a gateway, like this IMS. This is the client-facing service written in Flask. Then this thing would go to S3, fetch the image, do all the pre-processing. It will get a NumPy array, and then it will transform this NumPy array to protobuf. And protobuf, this is something you use to communicate to TensorFlow serving. So it would do all that and use gRPC for communicating to TensorFlow serving. And of course, we don't want our clients to even know about all these details, right? So they shouldn't care. All they care about is, hey, what are the categories for this image, right? So they just give us the image ID and get back the predictions. And we handle all this under the hood. We are pretty happy with TensorFlow serving. So it's fast, it's stable. So there was a bit of a learning curve because documentation is not always the best. So oftentimes we needed to find out about some things by looking at the code. But still, the community is supportive. So it's possible to ask things, and yeah, it's quite good. And the most nice thing about that, like when we moved from SageMaker to our own TensorFlow serving, it became a lot less expensive, like 4 times less expensive.
Thank you, and thank you for those questions. Somebody's also a fan of TensorFlow serving. Great, yes, keep them coming. I'd have another one. You said you sort of kept it broad and top line for the talk, so maybe could you go into a bit more detail about how you actually went about training the models?
Yeah, so we collect the data. Yeah, I think you can read about this in a blog post. So I already mentioned how we collect the data. So we use a Mechanical Turk. Then we also use the data that customers generated, like when they create an image, they select a category where this image would go. So we have this data. So once we have that, for training the model, we use SageMaker also. In SageMaker is super simple. So you can just put all the data you have in S3 and ask SageMaker, hey, SageMaker, this is my data. This is where it is in S3. And I want to train this model. And this is the snippet for training. And you just submit it to S3. So you need to have application to the data in S3 and the script for training. That's it. That's all you need to do. And then you submit to SageMaker. And then you select when you can say, OK, I want a GPU instance with 8 GPUs, for example. And then it spins up an instance. So it gets an instance, trains a model, saves the results to S3, and shuts down the instance. It's very convenient. So previously, like a few years ago, before SageMaker, we would need to maintain our own image with all these deep learning libraries. We would manually need to create it in EC2. I don't know, go there using SSH, train a model, and sometimes forget to turn it off, for example, after training finishes. But with SageMaker, it's easy. You just give it a script, the location, it trains. After finishing, it saves the results and shuts down the instance. It's super easy. It can be parallelized. So if you want to, for example, train, do some sort of parameter selection. So you can just say, OK, on this instance, I train a model with this parameter. And on this instance, I train the model with this parameter. And then you get the results, and you just keep the model with higher accuracy. So it's quite a convenient tool. And yeah, after that, after we have a model saved in S3, we go through the thing I described. So we put this model to TensorFlow serving and add it to this thing for serving.
Thank you. Another question. What are your thoughts about hyperparameter search using random search or hyperband with heavy deep learning models for image predictions?
Yeah, so I haven't explored, like with deep learning, random search is kind of difficult because there are many different parameters you can play with. So what I usually do is I first experiment, just using Jupyter Notebook, try to come up with like a rough architecture I want to use, like things with like learning rate and things like this, what kind of layers I have, like when I fine tune the model. And then there are some parameters like, I don't know, like the size of this dense layer at the end, or dropout, or things like this. And then I would just manually try them and see, like submit it to SageMaker and see which model is the best. So it's kind of semi-random. I mean, in a way that I just generate some parameters that look random to me, but I don't really spend a lot of time exploring different parameters, because at the end the models turned out to be quite good, and then maybe spending a lot of time just getting a few extra % is not always worth it.
Interesting, thanks. Yeah, I have another question, maybe until we get a few more. Also, Alexey, would you mind returning the hosting privileges to me? Then I can share the poll in a couple of minutes.
Okay, so let me see how I can do it. So now I stopped sharing, so now you can do this, right?
I'm still, because I made you the host. Alternatively, you could have a look if there's a poll option that you can share with everyone. Apologies for this to other participants.
So I think I just launched the poll.
Excellent. So why don't we do this now while I ask the next question to Alexey? Yeah, it's just 5 questions, should be really quick, and we'd super appreciate your feedback to make the next event, just know what we have to work on and improve. Yeah, so I was curious in terms of like current challenges you may be facing, or what you'll be working on to sort of further optimize looking towards the future.
So you can say it again, it's the challenges that...
Yeah, so I mean, you've addressed sort of challenges you've mastered in the past and changes you've made, but has anything new come up? What are sort of your focus in the future with this particular use case in terms of optimizing it further?
Yeah, so for this particular use case, I think it's pretty streamlined. So I'm adding new models is simple.
Mm.
What we want to do at OLX is use this experience, this learning to streamline model deployment across the organization, not just for these images, but for other types of models as well. So somehow have a platform that allows data scientists easily deploy models. So something like this, where you just train a model using SageMaker or Jupyter Notebook or whatever, like local laptop, and then just take this model and start using it immediately and making customer impact. Because what we found out that this is the most difficult part. Like training a model is easy compared to what is next. So of course, like there are many difficulties when training the model, but like it's even more difficult after that. Like all these infrastructural things and like all that, and we needed to learn it the hard way. Like to like starting with what is Kubernetes and how can we use it to, being able to actually talk about this. So it was quite a long journey.
Mm.
Now we want to make other people also take advantage of that and deploy their model faster. So this is more or less, this is what I'm doing right now at OLX. So helping data scientists ship their models faster to production.
We have a similar question, but maybe on a bit more personal, professional level. In terms of your favorite challenges that you're most motivated to work on, and also your least favorite challenges that you tend to avoid working on in this case.
Yeah, so I think, I answered about like, I'm pretty excited about that, like building a machine learning platform, like allowing people to make impact on business faster. I'm pretty excited about this. And I think like the whole thing called MLOps now is about that. How do we take the model that data scientists created and move faster with this? So I'm pretty excited about this deal. The thing I like least is probably tuning parameters. This is I'm not a fan of that. So some people do enjoy. I also at some point like this, but it's not my cup of tea. So I'm more into the steps after we train the model. So what do we do next after the model is there? How do we make it available?
Okay. I guess this is also quite dependent on the use case. In some cases, pushing at a few sort of percentages or even
yes, of course,
it really matters. And if it's not the case, then it's less to get out of it. Great. Okay. Does anybody have more questions? Feel free to share them. If not, perhaps in terms of, we might have some participants in the audience that are thinking about their own corporate contexts or potential use cases. Is there any like broader advice or like learnings that you would share sort of going beyond this particular use case that you presented?
Yeah, I don't know. So maybe can we ask it
again? It's a very broad question.
Yes. So.
No worries. What I'll do now is feel free. We'll have maybe do a minute or two to have more questions that you're just phrasing in your head. Just shoot them out. We do have one more. How would you onboard someone to be able to maintain your machine learning system?
Oh, that's yeah. Well, basically, so documentation and so having good documentation is important. Then doing some sort of pair programming, like, hey, these are the things that we have. Let's fix a bug together. Things like this. And this is like standard onboarding process for any software engineering product, like any software engineering service. So documentation. So make sure documentation is comprehensive as possible. So the person can start independently, And then once all the environment is configured, then take a few tasks, do them together, and then I think the person is ready.
Okay. A broader question, how do you handle the stakeholder management while communicating very technical projects? And how do you do knowledge sharing around that?
Well, so we have product managers who do stakeholder management. I also like wearing the hat of a product manager, do this talking and explain the difficulties of that. And yeah, so the best way is try to be as not technical as possible. So this is very difficult, I know. So perhaps talk to somebody who is not technical and ask them, hey, how much did you understand? Like, was there something that you didn't get? And things like this. Yeah, so basically before talking to real stakeholders, maybe take a product manager from your team or from another team and verify with them. And yeah, so it's a bit of it was a bit of a learning curve for me. So it becomes easier with the more you do, like basically practice makes perfect.
Great. We do have a couple more, so let's see if we can squeeze them in before the call ends. One was wanting to know a bit more about your approach to the documentation process. So I suppose it refers to maybe the tools, how to get people to document well.
Well, so one good way of testing if documentation is good is trying to onboard the person. So if the person cannot be onboarded, then documentation is bad, and it means that it needs to be changed. And usually what we typically do is when somebody is onboarded, then all the problems they have, we try to document them and put them to, so first of all, we use README in the actual Git repository when we keep the code. Then there is a higher level overview in Confluence, wiki, we use Confluence for that. And basically that's it. And also we do a bit of knowledge sharing, like we have weekly events where we talk about different things.
Great. And how regularly do you recurate your datasets and retrain your models in the long run?
So it depends on the problem. So of course, for some things like the distribution of data changes. So new things appear, some things don't appear anymore. And yeah, so we just put this everything to S3. We have a table where we add for each thing, like for every item, we in some cases, not everywhere, but we'll also try to keep some sort of versioning, like when was it added. And for example, in one project we use pachyderm, so this thing does that out of the box. But in some other projects, we do this by manually maintaining a database. In some projects, we don't do any curation. We just add more data and see what happens. Of course, not ideal, but in some cases, it's not worth the effort of maintaining this versioning. Like just add more data, see if it improves. If it doesn't improve, then you can just undo this easily. And retraining the models with SageMaker is very easy. So as I said, all we need to have is a script and location to S3 where we have the data. When we have new data, we can just maybe point to a different location, and then we basically re-execute the same thing. So from our point of view, this is just a command line in terminal. So you just put some code, hit enter, and then you retrain the model. And of course, if it can be done from a command line, you can also put this in CI/CD, like in GitLab or Jenkins or whatever, and just do it by clicking a button. So you see that, okay, now we need to have a new model, just click a button, and then you have a new model.
Excellent. And maybe a final, somewhat related question. Someone's wondering, data or algorithms, which of these two has more room to improve in your use case?
Yeah, of course, data. So algorithms, they are, so algorithms important when we talk about productionizing, because we cannot take the largest model with the most accuracy and just ship it to production, like for example exception ResNet or like inception ResNet or something like this. So there are bigger models, there are smaller models. We prefer smaller models because this way it's easier to scale it out. So and with that, of course, what we're left to do is when we use smaller models, of course, we basically need to make sure that the data is good. The data is representative of the, let's say, general population, like for images, like the training data with images we have. It's representative of the images we currently have today, these 10 million images. And sometimes it means we need to delete some things from our training data set. Sometimes we find out that the labels are inaccurate, so maybe we need to change the label or remove the row completely. So yeah, my answer is data.
You're certain. Great, thank you. It was great that everybody came up with so many more questions. So I wanted to make sure we get all those in. Thank you, Alexey. I learned a lot. I would assume everyone did. I have to use the opportunity, advertise for our next datalift event. That's on 27th November. So please feel free to sign up on the website or on LinkedIn and Eventbrite. And I hope you enjoyed this and got something out of it. And yeah, happy Friday and enjoy the weekend.